Hi everyone. Today I am discussing about the Legendre Transformation. This is the mathematical tool which are using in the thermodynamics. So in these tools we are discussing to how to any thermodynamics variable to without interchanging the information and without losing the information of that thermodynamics variables. So this is the use for this transformation to the natural variable to the Legendre transformation variable. Like as in this chapters we are changing the entropy into the temperature and volume into the pressure and moles into the uh, chemical potential. Okay, this is such type of changing in the natural variable to the Legendre transformation variable. This is the x is the natural variable and this is the theta is the Legendre transformation variable you are using in this chapter. Okay, first of all we know about the why the Legendre transformation, then already we are discussed about the why Legendre transformation we are need. So the here is writing here the change the natural variable without losing the thermodynamics information, and we saw here that is the actually we are discussing about the many of things like as the internal energies to convert into the enthalpy. So in this case we are using the Legendre transformation to easily to convert the internal energy to enthalpy, and our thermodynamic information is not losing in that case, and internal energy to Helmholtz Free Energy and internal energy to Gibbs Free Energy, and also interchangeable enthalpy to Helmholtz Free Energy and enthalpy to Gibbs Free Energy, and easily to convert the Helmholtz Free Energy to Gibbs Free Energy. This all will be the interchangeable in this using the Legendre transformation tools. And yeah, here we have been taking one example like as the internal energy. Yeah, many of the person will know about the internal energy. That is the formula of the internal energy using the classical thermodynamics is Q minus W. This is using in the classical thermodynamics del Q minus del W, and this will be the converted into the entropy format TdS minus PdV. Okay, and actually moles is the also interchangeable one thing. So in other than the classical thermodynamics we are using the du equal to TdS minus PdV and plus mu dm. So from this above equation we easily to find out the internal energy is the function of S, V and N. And next in this lecture, next after some time I will also discuss the how can I interchangeable U is changed to the enthalpy, and this is the Legendre using the Legendre transformation. Sorry, Legendre transformation. Using the Legendre transformation, and also U is the changing to S, also using the Legendre transformation, and S is going to Z, also using the Legendre transformation, and H is also you can easily to transform to Z. This is using to Legendre transformation. Actually one times Legendre transformation we are getting to the HRS from the U to this is the our like as the tree like structure to how to interchange all these things and getting the next term. Okay, that is the how can you get easily to know that enthalpy and oh sorry, here we are writing wrong. So okay, so yeah, almost Gibbs free energy is writing here. Okay, so here how to get the almost Gibbs free energy to Gibbs free energy. So from here we are directly to consequently change and then directly getting to Gibbs energy. Otherwise we are also getting from here to here and also getting from here to here, and same like as this is our tree like structure, we can move anyhow to anywhere. Okay, so we are moving the how to use the mathematical tool to using the legendary transformation. So in this chapter we are using like as the first of all we assume that the one function like as the y0 is the function of x. Okay, so here we have been the plot of the y-axis something like as, okay, and the here actually actually my line is not so good, so here is the some line is the plotting here, and we can easily to calculate the slope, and here is the intercept y1 and slope is the zeta. Okay, and this is the y versus x plot, y naught versus x plot. So here we know about the what is the zeta. Zeta is the dy0 upon dx. Okay, this is our zeta, and according to above line, okay, according to above graph, we write the equation of line is the y1 equal to y naught minus zeta x. Actually some person is interpreting some wrong things here, so actually we cannot be directly interpreted here, so we can be actually interpreted according to this y equal to mx plus c. So y is the here y naught and m is the zeta and c is the y1. Okay, so from here to here we can go and easily to interpret it this equation. Okay, so here we are also know one things here, that is the easily to differentiate this equation. Okay, so this will be the getting the y1 dy1 is equal to dy0 minus zeta dx minus x d zeta. Okay, and from above equation this is the zeta is equal to dy0 upon dx. From here we easily to get dy0 equal to zeta x zeta dx. Okay, substituting into the above equation and we get is the dy1 equal to minus x d zeta. So from this equation x is equal to minus d y1 upon d zeta. Okay, this is our standard equation, so easily to find out this thing. Okay, so also we can interpret it from here like as dy1 sorry dy1 equal to minus x d zeta. So here dy1 is vary with zeta, so y1 is the function of zeta. We can easily to say here that y1 is the function of zeta, and from here also to say y0 is function of x. So f g something like as change something. Okay, so this is our function. So this is the standard terminology to convert the all these things. So then I can summarize the all these things like as y naught is the function of x, and first legendary transformation is y1 is the function of zeta. Okay, and x is converted to zeta function. Okay, and the relation between in these terms is the y1 equal to y0 minus zeta into x. This is summarize the whole of these things. Okay, and some places also use some things, so I will discuss later all these things. So please remember these terms, remember these things. Okay, how to change the Legendre transformation and how to use the Legendre transformation using this thing. So we are moving to the next slide, and yeah, here actually how to transform the how to use the two successive transformation in Legendre transformation. Then in this case we are assuming that our function y0 is the function of x1 and x2. Then at least two function will be there, then we are assuming that our function will be successively two times will be transforming. Okay, so one first transformation will be the occur y1. Okay, so in that case y0 minus zeta 1 x1. Okay, and here x1, oh sorry, here we assume that yeah, y0 is the function of the dx1. So actually from this method we can calculate also using another method like as yeah, y0, sorry, y0 is the function of x1 and x2. Okay, so according to here the dy0 is equal to differentiation here, then dy0 upon dx1 at constant x2 dx1 plus dy0 upon dx2 at constant x1 dx2. And already we know about the x is equal to d del y0 upon, sorry, zeta is equal to del y0 by del x. Okay, so here will be the this term is the zeta 1 dx1 plus zeta 2 dx2. Okay, so we can easily to find out the zeta 1 and zeta 2 here. Okay, so first of all we getting the first transformation and y1, and first of transformation is x1 is converted to zeta 1. Okay, then we are getting that y0 is another function g will be the zeta 1 and x2. Okay, and this function zeta 1 and x2 is our function, and actually this is not our function, and this is not our function. Our function will be the y1 if we are converted zeta 1 into the Legendre transformation, then y1 is our function. This will be y0 minus zeta 1 x1, and y1 is the function of zeta 1 and x1. Okay, again we can differentiate and getting all these things here. So Here we saw that one thing from this equation. Yeah, this equation. dy1 equal to dy0 minus zeta 1 dx1 minus x1 d zeta 1. Okay, according to this information, from substituting here, and this will be the getting something like as minus x1 d zeta 1 plus zeta 2 dx2. Okay, so from here easily to conclude all these things, like as the y1 is the function of zeta 1 and x2. Okay, and same like as the second Legendre transformation will occur at that place is y2 is the something like as, where is our cursor of it? Sorry. Y2 is the y1 minus zeta 2 x2, and then also is writing here y2 is the y0 minus zeta 1 x1 minus zeta 2 x2, something like here. Okay, from substituting the y1. Okay, this is our successive to transformation and then getting it, and this transformation is using in the Gibbs free energy. Okay, and this transformation will be used to convert the enthalpy or almost Gibbs free energy. Okay, so easily we can conclude all these things.